You are going to take a 4-question true-false quiz and guess on every single problem. We want to know the probability of the various scores you could receive. So I'm going to start by creating a table to find all of the possible outcomes. So I know that I could get all 4 correct, which would give me a score of 100%. I could get 3 correct and 1 incorrect, which would give me a score of 75%. I could get 2 correct and 2 incorrect for a score of 50%. I could get 1 correct and 3 incorrect for a score of 25%, or I could get all of them incorrect for a score of 0%. So now I want to list all the different outcomes possible. So if I get all 4 correct, there's only one order that can happen, and that's getting all 4 correct. For 3 correct and 1 incorrect, I could start with 3 correct, 1 incorrect. Maybe I get the third one wrong. Maybe instead I get the second one wrong. Or I could get the first one wrong. So there's a total of 4 outcomes in that column. Okay, now I could get 2 correct and 2 incorrect. And I can change the order around of these different outcomes. So far I have 3. There's 4. Let's see. Correct, incorrect, correct, incorrect. Or I could do incorrect, correct, incorrect, correct, for a total of 6 different ways to get 2 right and 2 wrong. All right, now this 1 correct, 3 incorrect is going to be the exact opposite of 3 correct and 1 incorrect. So I'm going to start with 3 incorrects and a correct. Maybe I get the first 2 wrong and the third one right. Maybe I get the second one right. Or I could get the first one right. And finally, for 4 incorrect, the only option is that I just get them all wrong. So I see that there is 1 outcome here, 4 outcomes here, 6 outcomes here, 4 here, and 1 here. And I also see some symmetry. So in the middle there's 6, but as I spread out I see 4 and 4 and 1 and 1. And that is a total of 16 outcomes. Now another way you could determine the number of outcomes is thinking about, on the first question, I could either get it correct or incorrect, which is 2 outcomes for the first question. On the second question, I could either get it correct or incorrect. On the third question, I could get it correct or incorrect. And on the fourth question, I could get it correct or incorrect. And if I multiply all those together, I get 16 outcomes. This is also the same as 2 to the 4th power. In any binomial situation, we can do 2 to the power of how many events we have. 2 represents that there are 2 possible outcomes. The power of 4 represents that there were 4 true-false questions. So if I were to have 5 true-false questions, I would have 2 to the 5th power. And this will work for any binomial situation. Now that I know all the possible outcomes and the total number of outcomes, I can calculate the theoretical probability for each score. So the probability that I get 4 correct is going to be 1 out of 16. The probability that I get 3 correct and 1 incorrect is 4 out of 16, which simplifies to 1/4. The probability that I get 50% on my quiz is going to be 6 out of 16, or 3/8. The probability that I get 1 correct and 3 incorrect is again 4/16, or 1/4. And finally, the probability of getting all of them wrong is 1/16. And you see the same symmetry with the probabilities that you did with the total possible outcomes.